All right, so in this lesson, we are going to solve a system of equations. So solve a system of equations, once again, using elimination. We are going to use elimination because we'll be eliminating one of the variables, yeah. But this time we're going to provide evidence of solution. So provide evidence. So example 1, we have two equations, 2x plus 3y equals 6 and 5x plus 10y equals 15. So I will do this. Well, I'll allow a little room. 2x plus 3y equals 6 and 5x plus 10y equals 15. So I'm going to look for a common multiple. So 10, right? So I will multiply this one by 5 and this one by 2. Well, let me make that 5 a little better. And this equation by 2. Now, if you do this, you will get positive 10x and positive 10x, which would be an issue because we need a positive and a negative. So I'm going to make this one a negative. So 5 times 2x is 10x. Let me do that. 10x like that. Oh, I don't know why that looks weird. Okay, 10x. 5 times 3y, or positive 3y, is plus 15y. And then a positive 5 times positive 6 is positive 30. All right, so a negative, I'm going to do it this way. Negative times a positive is a negative 10x, which is what we want. Negative times a positive is a negative 20y. And a negative times a positive is a negative 30. Ooh, interesting already. So 10x minus 10x, eliminated. X's are eliminated. 15y minus 20y is negative 5y. Hold on, let me just make, okay, I did this right. I was checking something. And 30 minus 30 is 0. I will have to divide by negative 5. Divide by negative 5. So y equals 0. Now, let's substitute this into one of these equations. I like this first one. It looks cool, it's smaller. So 2x plus 3y equals 6. The y is 0. So 2x plus 3 times 0 equals 6. 3 times 0 is 0. Well, I can just cross it out, right? I'll cross it out that way. Okay, and we get 2x equals 6 divided by 2. And x equals 3. Cool. Let's see if there's a spot for me to put my answer. Nope. So I'll just write it right here. So 3, I'll just put solution. My solution is 3, 0. All right, the solution to my system, right? So the solution to this system of equations is 3, 0. This means that 3, 0 makes both equations true. Visually, both lines of solutions will intersect at this, I will say, point. All right, so now we're going to prove that 3, 0 is a solution to both of these equations right here. So I will start off with this one. So, well, I'm going to do this first. I'm going to write the solution here. Okay, and so we get 2x plus 3y should give me 6. So x and y, so x will become 3 and y will become 0. So 2 times 3 is 6, 3 times 0 is 0. You could also just cross it out. So 3 times 0 is 0. And 6 plus 0 is, in fact, 6. The left side of our equation is equal to the right side, at least in value. So let's do it with the next equation, or with the other one. So we have 2x plus 3y equal, I already did that one. Oh my goodness. So 5x plus 10y, I'll write that in blue. 5x plus 10y should give me 15. And 3, 0. So x and y. So it should be 5 times 3 plus 10 times 0 should give me 15. 5 times 3 is 15, plus 10 times 0, which is plus 0. So that's plus 0. I don't know why. Okay. Should give me 15. Oof, I'm having issues right now. And 15 plus 0 gives me 15. Cool. So, next page. All right, so we have example number 2. 5x minus 3y equals 6, and negative 5x plus 3y equals negative 6. I am going to show you something. So if we end up with 5x minus 3y and equals 6, and we stack this one, negative 5x plus 3y, oops, let me make this a little closer, plus 3y equals negative 6. Now, you can see that if we combine these equations, this one will give me 0. Or like, we have 0 x's, right? And then we get 0 y's, and then we get 0 here. What this essentially means is that both equations have the same exact solutions. They're the same equation in a different form. You can see, like, times negative 1, and you get that one. Or times negative 1 that way, and you get that equation. So let's see. So both equations. I'll just put the equations. Yeah, it's gonna seem weird. I was gonna put both, but I think that's not technically right. So I'm just gonna put the equations have no common. Oh wait, that's wrong. They are the same line. They are the same equation. So the equations, or both equations, there we go. This time it'll work. Both equations share the same solutions. And the number of solutions never ends. In other words, there are an infinite amount of solutions. What it basically means is, oops, I put salute, don't know why. Solutions. What this basically means is that if an xy works in this one, then it will work in this one. And if another one works in this one, then it will work in this one. So like they're the same. That's why when you try to put them together, everything goes away. So here, once again, we'll put infinite solutions. Ooh. And I can do a little better than that. A little. Okay, infinite. Oh my goodness, what is wrong with me? Infinite solutions. Maybe I need to replace the pen tip that I'm using. Infinite solutions. So these are, y'all understand what it means at this point, so I don't need you to write it out. And so let's go to the next page. So we have 8x minus 2y equals 5 and negative 4x plus y equals 1. So 8x minus 2y equals 5. And we get negative 4x plus y equals 1. Now we can tell, I can just make this a negative 8x here, right? So I'm going to multiply by 2. So 2 times negative 4 is negative 8x. And then 2 times positive y is plus 2y. And then 2 times positive 1 is 2. I'm going to bring this one back down here. I guess I can show it to you like this. Bring this one back down. Oh, I'll put it a little further away. And I will write 8x. 8. Ooh, I don't know what's happening. 8x minus 2y equals 5. So I will put another arrow just in case you didn't quite understand. Okay. So if you notice, these 8x's will cross out. We end up with 0 x's. And we end up with 0 y's. But this time we don't end up. We end up like with 0 here. We end up with like 7. If this ever happens, this doesn't mean that there's infinite solutions. This means that they will never like share a common solution. There are no common solutions. What this really means, if you change this actually, is that they'll have the same, remember they'll have the same slope, different y-intercepts. You don't need to remember all that, but basically if you end up with a number and like these are gone, like 0x and 0y equals 7, then that means the equations have no common solution. So the equations have no common, I'll write that a little better, no common solutions. Another way of saying that, or another way of saying this is there is no solution to the system of equations. So let me make sure that sounds right. The equations have no common solutions. Another way of saying this is there is no solution to the system of equations. I guess I could have probably made this better, but that works. So under solution, there's nothing, there's no common solution. So like no solution to the system. Like nothing will work for both. No XY will work for both of these. So, and that's it really. Thank you.